Uniswap v4 could challenge AAVE for 8 billion. Everyone wants to build a lending protocol, right? They're able to capture large amounts of TVL and generate sustainable protocol revenues through fees on borrowers. But the network effects of lending protocols are also very strong, requiring coordination between lenders, borrowers, and liquidators across many token markets. Uniswap v4 makes an entirely new lending protocol design possible. By making liquidators effectively relevant, v4 can compete with the likes of AAVE and Compound for TVL. So in this video, I'll describe how v4 can compete with those lending protocols, and we'll discuss, three things: how these protocols work in detail and what they have in common. Two, we'll display the significant advantages they have, especially the risk management layer versus existing protocols. And then third, we'll look at three different possible designs that could become, $8 billion TVL protocols. But before we start, let's recap what v4 has even to do with lending protocols, right? It's in fact an AMM platform. Well, yes, v4 is effectively a platform that allows you to build your own AMM, right? The key innovation in v4 is hooks, which are external contracts that execute specific actions at certain points during the execution of a liquidity pool, right? What are those points? Well, there's four: initialization, modify position, which is basically adding, removing liquidity. There's swaps, and there's donations, which is just an additional way to reward LPs with custom rewards. And then in each of these cases, we can inject custom Solidity code by a third-party developer, right? And so these hooks can be used in many different ways, including new order types, dynamic fees for AMMs, and so on. So basically build your own kind of mini AMM, right? And hooks really allow you to control where a liquidity provider capital is used, as well as introducing additional roles, right, in your hook. The practical implementation is basically just declare which hooks you're using, and then you start implementing custom Solidity code, right, that does something in those hooks. So the design space is quite vast, but the things that are interesting for us: hooks can help kickstart liquidity flywheels in your AMM-like protocol by providing access to order flow, which then in turn attracts LPs, right? So as long as your protocol can benefit either from having swappers, aka order flow, or from having LPs that order flow attracts, you can build it as a hook. And turns out lending protocols depend on both in an elegant way, right? So how does that actually work? Well, the way these lending protocols work is recognizing that hooks respond to price changes, right? Hooks respond to price changes because you have this kind of swap callback. Traditionally, you require liquidators, right? Traditionally, you have liquidators and you give them 7% fee to kind of monitor and liquidate positions that are insolvent. A hook doesn't need a dedicated liquidator role. It can use LP capital, right? LP capital is the liquidator, and that's really the unlock here. So let's consider a simple example, right? We have a ETH USDC pool, and ETH price is 1,500 USDC, right? Let's not use dollars for confusion here. So now there will be tick liquidity sitting at lower prices, right? So we may have tick liquidity like 1,300, 1,000, or whatever. There's actually quite a lot of ticks in between those, but for simplicity's sake. So let's now assume that there's a swap coming in. Well, this will result in an ETH price drop, right? That's the first action. And so now liquidation should happen, right? Because if there's an ETH collateral position that is liquidatable at that price, it should be liquidatable. So how can we do it? Well, we basically take liquidity from the USDC sitting at the lower tick, right? So if we had USDC sitting at 1450, right, and the price went that low, we're going to use that USDC to liquidate, right? Why? Well, what are the other options? Where else could we grab liquidity from? Well, we could take out of range liquidity above, but that's ETH, right? That's not a USDC, so we can't use that for liquidations. We could use swap liquidity, but it's also ETH, right? Because the swapper is selling ETH to us. We could use in-tick liquidity, but that's mixed. It's some mixture of ETH and USDC, so it's not very clean, and it's also being used obviously to kind of liquidate the prior position. So actually it makes much more sense to just use directly the LP capital as the liquidator, right? So let's summarize. Lenders come in and lend USDC, right? Lenders is going to be another role that's kind of added to the hook. Borrowers put up ETH as collateral in a tick. And we can call this negative liquidity. Why do we call it that? Well, if we look at traditional LP liquidity as kind of positive liquidity, this negative liquidity is gonna basically offset the swap fees of normal liquidity provider positions, right? By choosing a tick, borrowers basically can select their own collateral ratio and liquidation threshold, right? So they can basically pick the price at which they can be liquidated. And so when a swap comes in, LP capital is first used for liquidations and then used for swaps, right? LP capital first, liquidations, and then swaps. So basically, this idea of borrowers creating negative liquidities is just a way of saying that this LP capital is first going to be used to kind of swallow up borrower collateral, right, or the negative liquidity, and only then used for swaps, right? So the net liquidity that the pool is providing to swappers is actually lower, right, than liquidity that it seems to be providing, right? Okay, so that's basically it. Like all these protocols work in the same way, right? The key thing is that we have this LP capital sitting there and being able to be used as a liquidator. We don't need to incentivize outside liquidators whatsoever. So kind of what remains? Like what else is there to design? Like isn't that enough? Well, no. So first, price manipulation. How do you prevent that, right? So the problem is that like most, there's kind of three ways of looking at prices. You can use Chainlink oracles, you can use TBOP oracles, and then you can use spot prices. And this is the worst. This particular design uses V4 spot price as the actual oracle, right? And that is highly manipulatable, right? You can manipulate spot price very cheaply by taking a flash loan in a given block. And so we need to have some way of offsetting price manipulation. We'll look into what those ways are. The second question is like, how do you reward LPs, right? Because you're taking away swap fees. So this is less attractive now to be an LP in a lending protocol than it is to be an LP in a normal traditional hook, right? A V3 style hook. So you have to provide some additional reward for this rehypothecated capital. So the third thing is, how do you tune the various fees, right? To make sure that there's incentives for lenders to come in, for there's incentives to borrowers to come in, and that there's incentives for liquidity providers yet to come in. So you should balance all these three factors out. Okay, what are the benefits of this, right? Benefits, like why is this interesting? Why is this different from a traditional lending protocol? Well, there's a couple. So, and like a lot of them boil down to risk management. So the problem with liquidations, right? Expensive, right? 7%. And they can result in cascading failures, right? So when liquidations happen, the collateral is being sold, which provides a further downward pressure, which may end up basically resulting in liquidations for other positions, which then requires that collateral to be sold, and so on and so on and so on, which is basically this like existential risk to lending protocols. And actually, unfortunately, like there's contagion which can apply from one lending protocol to another, right? To the extent of like depending on how they use price oracles. So this is an incredibly dangerous thing. This doesn't really exist in our current view of the world because the capital to basically sell that collateral just exists already in this pool, right? So we're not really adding, if anything, we're adding friction to price changes rather than creating further price changes. So it just works wonderfully this way. The second idea is like basically there's full flexibility here to use any liquidation threshold, like even up to 95%. So borrowers, typically in traditional lending protocols, they have to work with whatever collateral ratios the protocol has laid out, right? So you may have a collateral ratio for each asset, and you just have to go with that as in terms of your risk bound. Here, you pick the ticket which you want to get liquidated, right? So your collateral ratio could be very aggressive, and that provides a lot of flexibility to borrowers. Okay, what are the downsides? Okay, so there definitely are some, and the three main downsides are one. These pools really only work for pairs of tokens, right? By definition, this is a two kind of asset type thing. And actually lending traditionally benefits you from having all your lending positions in one place because that reduces your chance of being liquidated across any one of them. So there's not that efficiency here. You end up at pairs of tokens and your kind of lending positions end up being fragmented, right? The second one is liquidations are impermanent. You can get liquidated, but it doesn't mean that you get the money out, right? Depending on how you design the protocol, sometimes you can kind of revert back using this kind of impermanent loss idea in AMMs. So some cases collateral can erode if the collateral has to pay a liquidation fee, and we'll see a design that actually incorporates that. And then thirdly, borrowers need both lenders plus LPs to exist, right? This can be offset to some extent, but basically like in a traditional lending protocol, borrowers only need lenders. In this type of like V4 based lending protocol, borrowers need both lenders and LPs to exist. So it's just a lot more complicated to get a three-sided marketplace to work. Of course, protocols can resolve this by automatically lending out of tick, out of range liquidity, which makes LPs the main counterparty to borrowers, right? And that could be a cool thing where it's like instead of lenders and borrowers, it's basically LPs who are also lenders, and then borrowers. And I think that's where probably the design space will go. Right, so we've seen the benefits. What are actually the possible designs here? Well, I'm going to cover 3 designs by real teams that are being proposed right now. So the first one is by Instadap. So Instadap proposed this protocol called Fluid. And Fluid was this idea, and again, like, what are we trying to answer here? We're trying to answer these like 2 design questions of like, how do we prevent manipulation and how do we reward LPs? And like, they only differ really in these ways, not in many other ways. So with Fluid, they kind of looked at a bunch of insights from kind of building on top of AAVE and Compound and other lending protocols, and looked at how to use this sort of AMM model and this liquidation model. And what they came across was this idea, okay, well, let's use TWAP and Chainlink oracles to protect the price in the pool, right? So because we're using the spot price, we have to prevent manipulation. So let's have another backup oracle and check and prevent the spot price from moving if we see that oracle, right? So if we look for that, yeah, we can see uses an oracle system, combines Uniswap and Chainlink to ensure the most reliable and accurate pricing data. That is kind of their key idea, and this is kind of very similar to how lending protocols work today, right? Not that creative. However, I think they then kind of follow this up with another article, which is a second type of protocol, which was their oracless lending protocol on Uniswap v4. And this was a lot cooler, right? And this kind of article was the one where they started to really describe this concept of negative liquidity to the borrowers. So I really recommend checking this out. But the interesting thing is how they think about rewarding LPs. And they think about rewarding LPs through what's called a liquidation penalty. So the idea is that there's a continuous liquidation penalty, right? So as long as your position is starting to fall in the liquidatable category, you start paying at this liquidation penalty rate to LPs. So what's the nice property? Well, this solves market manipulation, right? They claim that by doing some analysis that effectively becomes so expensive to manipulate the spot price to try and like farm this liquidation penalty rate that you will not artificially be incentivized to put people in liquidations, right? If it happens, it happens, and LPs earn liquidation penalty rates, but this manipulation and attack will not be possible. So they kind of basically solve both these problems at once. They introduce a liquidation penalty which incentivizes LPs, but then it also is not manipulatable. So let's look at a third design, which is by Solva Network, and this is really, really nice. So Solva Network, again, is pretty similar. The one thing they do differently is that they have no liquidation rewards whatsoever. And this is really interesting. And they claim that this reduces manipulation, right? Because there is just no incentive to manipulate prices anymore. Because you just don't get anything, right? There's no penalty rate, there's no fixed liquidation rate that you have in the Fluid protocol. You literally just have nothing. So what do LPs get? Well, instead LPs get interest rates. They share interest rates with lenders. And so that's their idea. Some interest kind of goes to the lender right here, and then other interest goes to LPs in ticks. And the other innovation I think that it's really interesting with this protocol does is it noticed one thing. It noticed that when you have a liquidatable collateral position, it's kind of like a stop loss order. And so it said, well, if we're just using hooks as this like stop loss mechanism, why don't we just factor that out? Why don't we create a stop loss hook that allows anybody to post a stop loss and get penalized for having that stop loss order in place through this like interest accruing stop loss mechanism, which I won't go into more detail, but that's basically the idea. And then you have this like separate contract, which is actually the lending protocol. And the lending protocol allows, uses the stop loss protocol to handle these liquidations. But the stop loss protocol is entirely permissionless. So this hook could be also used by anyone else looking to post stop loss orders. So this is a really nice way to kind of factor out and can really recognize that the way these lending protocols work is that they're using hooks for stop loss. And this may suggest, for example, that there will just be one big, really kind of aggregated stop loss protocol that other lending protocols could tap into. So really interesting to kind of game this out. So at the end of the day, right, I think I've presented a clear blueprint for building lending protocols on V4, and it'll be interesting to watch which company can challenge existing protocol TVL. If you want more details on how the Instadap V4 hook works specifically, I've done an entire video of that, which you can check out here. And definitely also subscribe to the channel for more content. Thank you.